Hey everybody, and welcome to this video on functions. So without further ado, let's get right to it. Alright, so before we go ahead and start discussing functions, we got to know what a function is. So the definition of a function is a rule or mapping or relationship between values in which each input has exactly one output. I often like to think of a function in terms of a function machine. So here's our function machine, and you give this function an input, and note, this input can be anything, a number, a word, anything. And the function machine has its rule, and the rule is going to operate on that input, and it's going to do something to it, and it's going to give out exactly one output, which again can be anything. Note, we're often going to be talking about numbers. Now, there are three main ways for us to represent the inputs and outputs to a function. The first involves making a table with the inputs and outputs on it. So here's a table, and all we're going to do is under the inputs, we're going to list our inputs, and horizontally from them, we're going to list their corresponding outputs. So for instance, this function might, for an input of -3, have an output of -15. And if you think about it in terms of our function machine, it's like when -3 goes into our function machine, the rule operates it, and our output is -15. For an input of 6, we have an output of 30. For an input of 120, we have an output of 600. And I'm going to go ahead and list a couple more input-output pairs. All right. Just goes to show we can have fractions, we can have decimals, we could have whatever number we want in this case. And perhaps you've already found out the rule here is that the output is equal to 5 times the input. Let's give this rule a name. Let's name this rule George. So the rule George says that to find the output, take the input and multiply it by 5. Now note, every single time we put in an input, we get exactly one output. It's never the case that for one input, we get 2 or more outputs. So George is a function in this case because every input has exactly one output. Now note, there are of course far more inputs and outputs that we can find, but for now, let's just stick to the ones we've got and try representing it in a couple different ways. So another way to represent these input and outputs to this function is with something called a mapping diagram. So the first thing we're going to want to do is we're going to want to make a blob and label that inputs, and a blob and label that outputs. In our blob labeled inputs, let's put all of our inputs, and for the blob labeled outputs, let's put all of our outputs. And now that we have all of our inputs and outputs in their respective blobs, all we do is we connect our inputs to their respective outputs with lines. One note, it's totally okay that these lines happen to crisscross. We just want to make sure it's very clear which inputs go with which outputs. We could have just as easily written the inputs and outputs so all the lines went straight across. But you don't have to. These two different mapping diagrams represent the exact same information. The third way we have to represent these functions is with something called ordered pairs. An ordered pair is just a set of parentheses with two entries in it separated by a comma. The first entry in that set of parentheses denotes the value of our input, and the second entry in that set of parentheses represents our output. So in this case, we could represent the function George by the following ordered pairs. And as you can see, in every individual ordered pair, the first number is the input and the second number is the output that goes with that input. So these are the three ways we have of representing our functions.